Okay, today we're going to learn lesson 832. This is going to take us 2 or 3 days to do. This is just part 1. And this is actually one of my favorite lessons ever. And I'm kind of sad we don't get to do this in person, but I'm glad I at least get to do it through video. So our job today is to take this 4th degree polynomial, and we're going to find all of the zeros. We're going to find them exactly, not just approximately. And we're going to rewrite this equation in factored form. Okay, the first thing I want to talk to you about is the possible zeros. Okay, and the way you find the possible zeros is you multiply the a value, in this case is 1, with the, I don't know, we could call it the z value, whatever is the constant term at the very end. So obviously when we multiply 1 times 6, we get 6. And the possible zeros are plus or minus any factor of a times z. Now a is a real thing, we use a lot. Z is not really mathematically something everybody uses. It's just this constant term. Okay, and so those are the possible, I should say, integral zeros. An integral just means that they are integers. So plus or minus factors of 1 times 6, we have 1, 2, 3, or 6. So without really doing anything, the possible factors are 1, 2, 3, 6, -1, -2, -3, -6. The second thing we're going to do is we're going to look at our calculator to figure out which of these is actually an integral root. And the reason we even do this step to start with is if we get something really complicated, this at least gives us a picture of where we should be looking on our graph. For most of the ones we do, they're not going to be super complicated. You're not going to need to really narrow it down, but this is mathematically the way that you figure it out. So I've already put this into my calculator, okay, and hopefully you are doing the same thing. And when I look, I can see maybe it crosses at -2, -1, maybe +2, okay? So I'm checking to see where it looks like it crosses, and then I can look down here, oh yeah, -2, -1, and +2 are possibilities. It definitely does not cross at 3 or 6 or -3 or -6. And I can just verify on my table. I can see that -1, 0 and 2, 0. Okay, and I can keep going and I can see those are no zeros. Okay, so we said -1 and +2 are the integral zeros. So integral zeros are -1 and +2. And they are on our list, so that's just double checking. Okay, so what that means is when I factor, I'm for sure going to have x plus 1 as a factor. I'm for sure going to have x minus 2 as a factor. And then I'm going to have either 1 or 2 other factors here. And the calculator gave us a clue. If we didn't have any other integral zeros, this is going to be an x squared something. Okay, and it's okay when we factor it out. If the x squared term does not get factored any further, it's okay to leave something x squared, and I'm going to show you why. Okay, so we know 2 of the factors. We have to figure out what multiplies by these 2 things to get this. And so what I'm going to do is I'm going to divide one at a time, and you could pick either of these to start with. It doesn't matter which. I'm just going to go with x plus 1. And what I'm doing is I'm taking our original equation and I'm dividing by x plus 1. Okay, so hopefully you picked this up from the previous lesson. I'm going to start with the x to the 4th inside the box. And I'm going to check that off. And I'm going to move on and I'm going to say, okay, x cubed times x gives me x to the 4th, and x cubed times 1 gives me x cubed. I'm supposed to have -1, and I have a +1, so I need to subtract 2, because 1 minus 2 gives me -1. Okay. And then I'm thinking backwards, -2x squared. Remember, these are going to descend 1 by 1, so that's x cubed, that's x squared. And I'm going to multiply -2x squared times 1. Okay. but I'm supposed to have negative 5x squared, so I'm going to subtract 3. And then I'm going to go to negative 3x times x gives me negative 3x squared. Multiply by negative 1. I get negative 3x. I'm supposed to have a positive 3x. So I have to add 6 because negative 3 plus 6 will give me my positive 3 that I'm looking for. Okay. Let's see, back to red. So this would be a 6. And this is a 6. And this works. Meaning there's no remainder. If you get a remainder here, then we did something wrong. Okay. If we're saying that this is a factor, it means there better be a remainder of 0. Okay. So again, we used x plus 1. We divided it into this polynomial. Okay. And we're getting this answer. Now, we know our second factor is going to be x minus 2. And I don't want to go back and divide it using this. I actually want to divide it using what I have here. Okay. Again, technically speaking, what I just did was figure out this is x plus 1 times x cubed minus 2x squared minus 3x plus 6 from here. Okay. But again, if I have x plus 1, this factors down to x minus 2 times something. We already know that. So I'm going to put my x cubed here, okay, which gives me an x squared, negative 2x squared. I'm going to check that off. I'm supposed to have negative 2x squared. That's great. So I'm going to put a 0 here. Putting the placeholder in can really be important. You don't have to do it, but you really can get mixed up pretty easily if you don't. So 0, and I'm going to put an x here. It's not necessary, but I'm just going down in descending order, x squared then x. So 0x times x gives me 0x squared, and 0x times negative 2 gives me 0x. And again, yes, I know it's 0, but the placeholder is there to help me out. We already talked about the squared. And I'm supposed to have negative 3x. I don't have any, so I have to put a negative 3x here. Okay, so I put a negative 3 on top. I get 6 here. That matches. And again, it better match. If you don't get a 0 here, then that means it's not a factor. So what we just determined is, in factored form, we have x plus 1 times x minus 2 times x squared minus 3. Equals p of x. Okay, so this is my factored form. When they ask me rewrite in factored form, I've got it. I cannot factor that any further. Remember, when you factor, you don't use square roots, you don't use fractions. This cannot factor any further. Now, when it says find all of the zeros, we're just going to use the zero product property. Okay, so when it says find all of the zeros, I'm just going to say, oh, x plus 1 equals 0, x minus 2 equals 0. X squared minus 3 equals 0. These two are super easy. You guys have been doing those in your head. Like, if you don't show me this step, that's okay. I just want you to be reminded of where it came from. Okay, so I have 2 zeros, and we already knew that. We looked on the calculator. We saw it cross, the graph crossed the x-axis at negative 1 and 2, so we already knew that that was the case. These two are the ones that we didn't know. So if we add 3 to both sides, and then take the square root, please, 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 please remember, some of you guys are still forgetting. When you take the square root of something squared, you have to include a plus or minus. Okay? And hopefully it makes sense to you that there are 1, 2, 3, 4 zeros because this was a 4th degree polynomial. If this is a 5th degree polynomial, you should have 5 here. This is a 12th degree polynomial, you should have 12 answers here. Okay? So that's the big idea for this lesson. The second problem and the last problem that we're going to do today and that I want to show you how to do is actually a homework problem. It's 8-140, and I'm not really sure why they give this to you as a homework problem, like you're just supposed to figure it out, but that's why we're going to talk about it together. So we have done lots of work with complex numbers. You guys have added, subtracted, and multiplied. You found the absolute value, and you have graphed. But what we haven't done yet is divide absolute values. And in math, we don't leave a complex number divided by a complex number. We never leave it in this form, okay? So what our goal here is to get rid of the imaginary or the complex part in the bottom. And if you remember from previous lessons, two things. Number one, I can always multiply by a giant 1. Okay, so whatever I put on the bottom, I want to put the same thing on the top. Also, earlier in chapter 8, we talked about how do we turn the denominator into a real number. Okay, and we use the conjugate. So we keep it a -4, but we use -7i. And again, we can only multiply by a 1. So we're just multiplying by the same thing on the top and the bottom. Okay, so I'm going to use this board as my workspace. So again, I'm asking you to multiply 3 plus 2i times -4 minus 7i. And this is one strategy, the generic rectangle. Some of you will use FOIL, some of you can do it mostly in your head. But you have to be ready to explain and justify some work here. Okay, we haven't seen I squared in a little while, so just a quick reminder, when you see I squared, that's really a -1, so that really changes this to a +14. So when I combine like terms here, I get, let's do the real portion first. I have +14 minus 12, so that's 2, and I have -8i plus a -21i, so minus 29i. Remember, that's just the numerator. Okay, so 2 minus 29i, just the numerator. The denominator, we're going to do the same thing. Okay, I have -4 plus 7i, and I have -4 minus 7i. Okay, and use my generic rectangle, -28i, +28i, -49i squared. Okay, so again, that makes a zero pair. 28i, -20i, 8i, gone. That's the whole reason we chose the conjugate to multiply in the first place, so we can get rid of an imaginary number in the denominator. As mathematicians, we never leave an imaginary number in the denominator. Okay, I squared, again, that's really -1. -49 times -1 is 49. Add 49 and 16, and we get 65. Okay, so the denominator is simply 65. Okay, we're almost done. The very last thing, if you remember, for a complex number, we need to write it in a plus bi form. This is not in that form. So the last thing that I have to do is basically distributing 1/65. Okay, so I have 2/65 minus 29/65 I. Okay, so all we did from here to here, you could think of it as division of complex numbers. You can also think of it as simplifying or rewriting in a plus bi form. Okay.